Hi, my name is Becky Gonzalez, and this is my creative computing to represent Criterion 20, 21, and 22 of Artifact 11. The ISTE standards are managing technology and learning, design and computational thinking, and creativity. Description of my computing project: I taught a small group of students from my traditional classroom on how to program and make a digital animal using a microbit starter kit. Microsoft materials and laptops to code using MakeCode and microbit.org. I taught them how to brainstorm their ideas, think about steps to coding, and to be creative with the microbit materials to create a digital animal with movement. This lesson also included how to use a breadboard to utilize the microbit starter kit. I was inspired to teach this lesson after learning about the microbit in my college course. It was a fun way to get my students interested in technology and the beginning of coding. It also taught them how to create and design. I taught my students after school in my traditional classroom. The materials needed were the starter microbit kit, which is around $30. They needed to have access to a website link, makecode.microbit.org, small boxes, construction paper, glue, scissors, crayons, and obviously a laptop. I went over the online digital citizen rules for elementary school for my use of technology and guidelines and parameters. This is the setup for the creative computing lesson. I have my materials, my microbit kit, and construction paper, tape, scissors, things like that. My students first brainstormed their ideas. I modeled and showed them my computing project that I had from my course. They were very excited to get started and loved creating. Um, then I showed them the microbit and the features of it and what it was and how it works. Then we went to the coding website and looked all over. This lesson took about an hour and a half, or I planned for an hour and a half. It actually took about 3 hours and several sessions because they always wanted to improve their design. They were pretty excited about the design. Um, and then it took a lot longer to see the coding and to get the movements of the kit. The design process: first we decided to set a goal for the project and a problem we were trying to solve. We wanted to create an animal using a microbit that could display movements like a real animal. We gathered background information about the tools in the microbit, and I shared all the microbit capabilities. And then we had a discussion about how animals behave so that we could think about wings and bird sounds and movements of heads and tails and things like that. Then we planned for the project, including the animal's behavior and the components that we might have needed. I modeled some examples with them, and then we talked about the materials. And then we looked up a code example and taught them how to make the movements on the coding program and what we would have to do. And then we created our design. We used our plan and created our design and built it. Then we had to improve, which they love to do. They love to improve it as we went along and add more to it. Movements and speed variations and things like that. The design process: we asked and defined, started with the goal like I discussed, we planned it, brainstormed it, we created it, then we improved it at the end. Creativity and problem solving: to intentionally model and nurture creativity and creative expression in my project, I use the 4P framework: projects, peers, passion, and play. The projects: I designed the digital animal project as an open-ended task, allowing room for individual expression. With peers, they collaborated with each other, working in a small group, exchanging ideas and giving feedback to each other. And then the passion: I encouraged the participants to choose an animal or theme they were passionate about, asking them to think about their personal interests. And then for play, I incorporated a fun approach, creating a relaxed environment where experimentation was encouraged. My computational thinking: design into a digital animal with a microbit can be broken down as abstraction. I simplify the project by focusing on key animal behaviors. Decomposition: I broke the project into smaller tasks. It took longer than the hour and a half I had planned. It took 3 hours to get it all in. And then the pattern recognition: I identify the common actions like how a button press trigger outputs to reuse similar code patterns so they could repeat the coding. Flapping wings and blinking eyes and things like that. The algorithms: I discussed clear step-by-step instructions so we could guide the animal's behavior. Um, and then debugging and testing: I tested and we fixed individual behaviors, and we had to fix chords and adapt the box to fit the eyes and things like that. That were just part of the design process.